The sound is deafening. Millions of glass bottles cascade down into a giant industrial machine, creating a symphony of shattering that echoes throughout the factory. In a matter of seconds, what were once discarded containers transform into a brilliant shower of multicolored fragments, each piece reflecting light like tiny industrial diamonds. But here's the fascinating paradox. These broken bottles aren't being destroyed, they're being reborn. In just 24 hours, these same fragments will emerge from this factory as completely new bottles, indistinguishable from the originals, ready to begin a new life cycle. How is it possible that something apparently destroyed can return to its original form with absolute perfection? How does an industry manage to process 80 billion recycled bottles annually, transforming what would be waste into products identical to the originals without losing quality or purity? The answer lies in the most elegant and sustainable technology of modern industry: glass recycling, a process that challenges our perception of waste and renewal, where destruction is merely the first step of an extraordinary transformation. Prepare to discover how science and engineering unite to create one of the most perfect cycles in industrial nature, where the end is always a new beginning. The history of recycled glass is as ancient as glass civilization itself. Over 4,000 years ago, Mesopotamian artisans already discovered that broken glass pieces, called cullet, could be remelted to create new objects. It was an accidental discovery that would become one of humanity's most sustainable practices. In ancient Egypt, glassmakers realized that adding glass fragments to the furnace not only saved precious materials, but also drastically reduced the temperature needed for fusion. What previously required furnaces at 1,700 degrees could now be achieved at 1,500 degrees, a revolutionary energy savings for the time. During the Roman Empire, glass recycling became an established commercial practice. Specialized merchants traveled through cities collecting broken glass fragments, which were sold back to glassmakers. It was the first organized circular economy system in history, 1,000 years before the term was invented. The true revolution came in 1884, when Michael Owens invented the first automatic bottle-making machine. Suddenly, mass production became possible, but it also created an unprecedented problem: what to do with millions of discarded bottles. The answer came during World War II, when raw material shortages forced industries to rediscover recycling. Government campaigns encouraged citizens to collect glass for victory, transforming household bottles into ammunition and military equipment. It was during this period that the first modern glass recycling processing technologies were born, establishing the foundations for the billion-dollar industry we know today. The transformation process of broken bottles into new ones begins long before the factory, on the streets, homes, and commercial establishments worldwide. Selective collection is the first link in this extraordinary chain, where millions of people unconsciously participate in one of humanity's largest collaborative engineering projects. When collection trucks arrive at sorting centers, the first critical phase begins: color separation. Advanced computer vision machines, equipped with optical sensors, identify and separate glass into three main categories: clear, flint, green, and amber. This separation is crucial, as each color has specific chemical properties that must be preserved. The second stage is intensive cleaning. Industrial washing systems remove labels, adhesives, metal caps, and organic residues through a combination of pressurized water jets, biodegradable chemical solutions, and density separation. Magnetic detectors and eddy currents eliminate any microscopic metallic contamination. Next comes the most spectacular moment: controlled fragmentation. Specialized crushing machines break bottles into uniform pieces of 12 to 25 millimeters, the ideal size for homogeneous fusion. Each fragment is inspected by X-ray systems that automatically detect and remove any foreign material, such as ceramics or stones, that could compromise the final product's quality. The resulting material, now called clean cullet, undergoes a final inspection through high-precision optical separators, capable of identifying and removing impurities smaller than 1 millimeter. The result is exceptionally pure material, ready to be reborn as new glass. At the heart of the glass recycling revolution are technologies that seem straight out of science fiction films. Regenerative melting furnaces operate at precise temperatures of 1,500 degrees, using heat recovery systems that capture and reuse 85% of the thermal energy that would otherwise be lost. These furnaces operate 24 hours a day, 365 days a year, maintaining a constant temperature that could melt copper. The most impressive innovation is the automated batch feeding system. Computers control the exact mixture of recycled cullet, up to 95% of the total, with virgin raw materials, adjusting composition in real time based on instantaneous spectrographic analyses. Laser sensors monitor the viscosity of molten glass, ensuring each drop has the perfect consistency for molding. Modern IS, individual section machines, are true marvels of precision engineering. Each machine has 8 to 20 independent sections, each capable of producing one bottle every 2 seconds. Computer-controlled pneumatic systems mold molten glass through a synchronized dance of molds, blowers, and transferers, all operating with tolerances smaller than 0.1 millimeter. Hot-end coating technology applies a microscopic layer of tin oxide to the surface of still hot bottles, increasing their strength by 300% and reducing the probability of breakage during transport. Computer vision systems inspect each bottle in 360 degrees, detecting defects invisible to the human eye through optical stress analysis. Artificial intelligence continuously optimizes the process, learning from each batch produced and adjusting parameters to maximize efficiency and quality. Machine learning algorithms predict equipment failures before they happen, enabling preventive maintenance that keeps production uninterrupted. The obsession with perfection in glass recycling borders on scientific fanaticism. Each bottle produced undergoes 47 different quality tests before leaving the factory, from microscopic chemical composition analyses to resistance tests that simulate decades of use in minutes. X-ray fluorescence spectrometers analyze glass chemical composition in real time, detecting variations of less than 0.01% in element concentration. This precision ensures that recycled bottles have exactly the same physical and chemical properties as originals: identical transparency, thermal resistance, and durability. Pressure inspection systems test each bottle by applying controlled internal pressure, simulating the most extreme use conditions. High-speed cameras capture 10,000 frames per second during these tests, revealing invisible microfractures that could cause future failures. Total traceability allows each bottle to be tracked from original cullet to final product. Microscopic laser-engraved codes contain information about production date, raw material batch, melting temperature, and even the identity of the machine that produced it. If any problem is detected, specific batches can be tracked and isolated within minutes. Quality control laboratories operate 24 hours a day, performing accelerated aging tests that simulate 20 years of use in 48 hours. Thermal shock tests subject bottles to extreme temperature variations, while impact tests use calibrated projectiles to verify breakage resistance. Final certification is only granted when each batch meets more than 200 different quality parameters, ensuring consumers receive products indistinguishable from bottles made with virgin materials. Glass recycling represents one of the most impressive success stories in industrial sustainability. For each ton of cullet used, the industry saves 1.2 tons of virgin raw materials, sand, limestone, and soda ash, preserving finite natural resources and reducing destructive mining. Energy savings are even more dramatic. Using recycled cullet reduces energy consumption by 30% compared to production with virgin materials. This happens because recycled glass melts at lower temperatures, requiring less fuel in furnaces. In practical terms, this means each recycled bottle saves enough energy to keep an LED bulb lit for 4 hours. CO2 emission reduction is another extraordinary benefit. The global glass recycling industry avoids the emission of 12 million tons of CO2 annually, equivalent to removing 2.6 million cars from the roads for an entire year. This reduction comes from both lower energy needs and decreased chemical processes that release gases during virgin raw material fusion. Modern factories implement closed-loop water systems, recycling 95% of water used in cleaning and cooling processes. Advanced filters remove microscopic particles, allowing the same water to be reused dozens of times before final disposal. Renewable energy increasingly powers these operations. Solar panels and wind turbines generate clean electricity, while biomass systems use local organic waste as alternative fuel. Some factories have already achieved carbon neutrality, producing more clean energy than they consume. The impact goes beyond the factory. Each ton of recycled glass prevents 2 cubic meters of landfill space from being occupied, extending the lifespan of these sites and reducing the need for new landfills. The glass recycling industry's biggest nightmare has a name: cross-contamination. A single ceramic fragment or tempered glass piece can ruin tons of cullet, creating stress points that make bottles explode spontaneously. The solution came through near-infrared detectors that identify different glass types by their unique molecular signature, removing contaminants with surgical precision. Seasonal collection variations created another complex challenge. During holidays and special events, collected glass volume could vary by 400%, overloading processing systems. Engineers developed modular storage systems that expand automatically, like giant industrial accordions, accommodating demand peaks without interrupting production. Color mixing represented a fascinating technical problem. Green glass contaminated with just 0.1% amber glass completely changed color, becoming unusable for certain applications. The revolutionary solution was developing trichromatic optical separators that use 3 different types of laser light to identify and separate colors with 99.97% precision. Transportation logistics almost made the industry unviable in the 1990s. Transporting broken glass was dangerous and expensive, with freight costs representing 60% of material value. Innovation came through pneumatic compaction systems that reduce cullet volume by 75% and specialized containers with anti-puncture lining that eliminated transportation accidents. The most recent challenge is total automation. Robots need to handle sharp and heavy material in high-temperature environments, a combination that destroyed conventional equipment. Robotic arms with ceramic coating and thermal vision systems now operate in conditions that would be lethal to humans, simultaneously increasing efficiency and safety. Recycled glass transcends its origin as a simple bottle, transforming into an infinity of applications that shape our modern world. Premium wine bottles made with 95% recycled glass preserve flavors for decades, their unchanged chemical properties ensuring each sip is exactly as the winemaker imagined. In the pharmaceutical industry, recycled medicine bottles protect life-saving drugs, their absolute chemical purity ensuring no contamination compromises critical treatments. Vaccine vials made with recycled glass travel to the planet's most remote corners, keeping medication stable in extreme conditions. Modern architecture has embraced recycled glass as a sustainable building material. Skyscraper windows, made with up to 60% recycled material, filter sunlight while maintaining energy efficiency. Each glass panel in a commercial building can contain fragments from hundreds of different bottles, creating a silent symphony of sustainability. The food industry critically depends on recycled glass packaging. Preserved jars maintain food for years without altering taste or nutritional value, while olive oil bottles protect premium oils from oxidation and light. Each container is a molecular guardian, maintaining its contents' integrity through perfect physical properties. Specialized industrial applications use recycled glass in surprising forms. Glass fiber for thermal insulation, glass spheres for reflective road signage, and even bioactive glass for medical implants that naturally integrate with human bone tissue. The cycle completes when consumers unknowingly buy products packaged in glass that may have been recycled dozens of times, each iteration maintaining absolute quality and purity, a testament to the perfection of the circular economy. The future of glass recycling is being rewritten by technologies that seemed impossible just a decade ago. Quantum artificial intelligence promises to optimize fusion processes at molecular levels, adjusting temperature and composition with atomic precision to create glasses with custom properties for specific applications. Nanotechnology is revolutionizing color purification. Microscopic nanorobots, smaller than viruses, can identify and remove individual contaminants, elevating recycled glass purity to levels superior to virgin materials. This technology will enable recycling of glasses previously considered unrecoverable. 3D printing with recycled glass is emerging as a fascinating frontier. Specialized printers melt cullet at controlled temperatures, creating complex objects directly from recycled material. Architects are already designing entire structures that will be printed using glass from discarded bottles, completely eliminating the need for traditional molds. Smart, recycled glass will incorporate molecular sensors that monitor content quality in real time. Wine bottles will alert when the product reaches ideal maturation, while pharmaceutical bottles will automatically detect medication degradation, changing color to warn about expiration. Molecular recycling represents the industry's holy grail. Technologies in development will be able to break glass into its basic atomic components, allowing complete molecular structure reconstruction. This will forever eliminate color and composition limitations, creating a truly infinite recycling system. Autonomous factories will operate without human intervention, using AI to optimize every aspect of production. Drones will collect glass directly from residences, robots will process material automatically, and distribution systems will deliver final products without humans touching the process. A silent industrial revolution powered by sustainability. The journey of billions of broken bottles that are reborn as new ones reveals one of the most elegant achievements of human engineering. From brilliant fragments cascading down to perfect bottles emerging from production lines, we witness a cycle that challenges our perception of destruction and creation. 80 billion bottles recycled annually represent more than numbers. They're testimony to a silent revolution that transforms waste into resource, problem into solution. Each recycled bottle saves enough energy to power a house for hours, avoids CO2 emissions equivalent to kilometers of driving, and preserves natural resources for future generations. The revolutionary technology behind this process, from quantum detectors to regenerative furnaces, from artificial intelligence to advanced robotics, demonstrates how innovation and sustainability can dance in perfect harmony. Machines operating with atomic precision, systems that think and learn, processes that continuously self-optimize. Absolute quality emerges from this technological complexity. Recycled bottles are indistinguishable from originals not by chance, but by meticulous design. Each test, each inspection, each control parameter ensures recycling is not just sustainable, but superior. The positive environmental impact transcends the factory, creating waves of benefit that spread across the planet. Less mining, less energy, fewer emissions, less waste, a cascade of improvements proving industry and nature can coexist harmoniously. This is the story of how humanity learned to imitate nature, where nothing is lost, everything is transformed. Glass recycling is not just an industrial process, it's a life philosophy, a promise for the future, proof that we can do better. Now that you've discovered the secrets behind transforming billions of broken bottles into new ones, one question remains. What will be your contribution to this extraordinary cycle? Every bottle you place in recycling isn't just waste being discarded. It's raw material for a technological revolution happening 24 hours a day in factories around the world. You are an integral part of this sustainable innovation chain, an essential collaborator in humanity's largest circular economy operation. Share this story with friends and family. Let them discover how something apparently simple like recycling a glass bottle connects to cutting-edge technologies, artificial intelligence, and precision engineering. Show them that sustainability isn't sacrifice, it's evolution. Tell us your experience. What was the most surprising moment of this journey? Did you imagine glass recycling involved such advanced technology? What other industrial processes would you like to see unveiled with this level of detail? Challenge yourself to see the world with new eyes. The next time you hold a glass bottle, remember you might be touching material that has already lived dozens of previous lives, each one contributing to the perfection you hold in your hands. The glass recycling revolution continues, and you are part of it. Together, we're building a future where nothing is lost, everything is transformed, and innovation serves sustainability. Special thanks to the leading companies in the glass recycling industry that opened their doors, metaphorically, to reveal the secrets behind this extraordinary technology. To the teams of engineers, scientists, and technicians who dedicate their lives to perfecting processes that make our world more sustainable. Deep gratitude to industrial sustainability experts, advanced materials researchers, and visionaries who continue pushing the limits of what's possible in modern recycling. Your contributions make it possible to transform the impossible into daily routine. Special recognition to the millions of people around the world who participate in selective collection, becoming involuntary collaborators in this technological revolution. Each correctly discarded bottle is a vote of confidence in a sustainable future. And primarily gratitude to you, our reader, for dedicating your time to understanding the complexity and beauty behind processes that normally remain invisible. Your curiosity and interest fuel our passion for unveiling the secrets of the factory-made world. Research and narrative, factory-made team, technical consulting, materials engineering, and industrial sustainability specialists. Scientific review, glass technology laboratories continue exploring with us the mysteries of modern manufacturing. The world is full of extraordinary processes waiting to be discovered. This documentary and narrative format reveals only a fraction of the technological wonders that surround us daily. The next time you recycle a glass bottle, remember, you're participating in one of the most beautiful symphonies of human engineering.